Hello, seventh grade. This is Mrs. Lopez. We are working on Module 3 now, and we are in the first lesson. Module 3 has to do with equation solving, one step and two step. Lesson 1 is the introductory lesson. It talks about how to generate equivalent expressions. It talks about how to combine like terms, and it also talks about additive and multiplicative inverses. So, quite a few little things there. But again, we are just introducing our topic, our module. So, we are going to start with important vocabulary that you need to learn and use in your everyday uh, life, everyday math classes. First one is term. Term, and we will want to underline that word. Term. Term is when each summand of each summand of an expression in expanded form. What that means is when we have an expression, for example, 2x plus 3x plus 5, each term is going to be separated by the plus sign all the time. Even though 2x is 2 times x, it's still one term because 2 and x are not separated by the plus sign. Terms are always separated by the plus sign. Plus sign separates the terms. So there are three terms in this expression. It's 2x, 3x, and 5. Variable. Variable is a symbol. Usually it's a letter that represents a number. For example, in the term 2x, x is the variable. It's a letter that represents a number that we don't know yet, and sometimes we don't even need to find out. Just a letter. Numerical expression is a number, or it is any combination of sums, differences, products, or divisions of numbers that evaluates to a number. So numerical expression or a number problem that consists of numbers, just numbers. And expression doesn't require an equal sign. So this is just an expression. When we have an equal sign, it will be a different word. It will be already an equation. Next one is expression. Expression is a numerical expression, or it is the result of replacing some or all of the numbers in a numerical expression with variables. So this is an expression, not numerical one anymore because we already have variables here. 3x plus 2y plus 6. That's an expression. It doesn't have an equal sign. It's just a bunch of numbers put together using addition. Equivalent expressions. Equivalent expressions that represent the same value. For example, 4 plus 5 is 9, 6 plus 3 is 9. They are equivalent. They have the same value. Expanded form is another one. Expanded form, an expression that is written as sums and or differences of products whose factors are numbers, variables, or variables raised to whole number powers. So for example, x plus 2x plus 3x is going to be expanded form because we actually can combine them. Standard form, an expression where like terms have been combined. So for example, 2x plus 3x, this is an expanded form. And when I combine them, it's going to be 5x. 5x is going to be the standard form. And I totally forgot to move my paper. Sorry. So again, you didn't see the expanded form. Expanded form is x plus 2x plus 3x. It's a bunch of terms that I actually can combine. And standard form, it's an expression where there is nothing else to combine. So for example, 2x plus 3x is expanded form. But when I combine them, I will have 5x. And 5x is standard form. There is nothing else to combine. Coefficient. Coefficient, the number found by multiplying just the numbers in term together. For example, 2 times x times 4 is equivalent to 8x. 8 is the coefficient of term x. So basically, coefficient is a number that is multiplied by the variable. A number that is multiplied by the variable. Coefficient is just a number. Variable is just a variable. Okay? There's a couple more words that we are going to use, but they're not here. So I would like you to write those down just underneath. First one is constant. Constant. Constant is a number that does not have a variable next to it. A number that does not have a variable. That does not have a variable. Constant is a number that does not have a variable. For example, 5, 2, 2/3, 10, -2. Okay, so these are all constants because they're not multiplied by their variable, just numbers. Constant. In one more word is like terms. Like terms. Like terms are terms that have the same variable. That have the same variable. Like terms are terms that have the same variable. For example, 3x and 2x. They are like terms because their variable is x. 3y and 2y, they will be also like terms because they will both have y's next to it. Okay? So let's try to apply all these words using them in our problems here. So in number 1, in exercise 1, they're asking us to combine like terms. So right away, we have two new words, terms and like terms, that we need to know. So we know that terms are separated by the plus sign, and like terms that have the same variable, or even don't have it. They just numbers, right? So for example, 3 plus 7 plus 2. 3 plus 7 plus 2. The terms are 3, 7, and 2. They're separated by the plus sign. Neither of them have variables attached to them. And this is a problem that every second grader or first even knows how to solve. 3 plus 7 is 10, 10 plus 2 is 12. All right, so I can write that equals 12. Okay, I just simplified my expression. I made equivalent expressions. 12 equals that. Next one is 2x plus 3x. 2x and 3x. Both of them have x's. Instead of x, let's call them apples. Apples. So I have 2 apples and I have 3 apples. If I combine those apples, I will have 5 apples. 5 apples. So when I have 2x and 3x, I will have 5x. 5x. Next one, 3x plus 4 plus x. 3x plus x is like 3 apples plus an apple, and that is going to be 4 apples. 4 apples, or 4x, plus 4. 4 does not have a variable next to it. 4 does not have a variable next to it, so we cannot call it apples. It'll be something else. So 3 apples plus 4 plus an apple. I will still have 4 apples, and that 4 is still attached to it, but I can't combine them. Okay? Let's look at next one. 2y plus 3x plus 5. These are all different. Neither of them is like term to a different one. So we have y's, we have x, and we have just a constant 5. We cannot combine them. They are different. It's like pears, apples, and carrots. I cannot combine them and call them all apples. Okay? So we cannot combine them. my answer to this one will be the same. 2y plus 3x plus 5. There is nothing I can do. It's already written in standard form. 4x minus 2x. Even though you know what 4 minus 2 is, I would always ask you to change your subtraction into addition of the opposite, because the more you practice with it, the easier it's going to become. So I'm going to change minus into plus the opposite. So I will have 4x plus negative 2x. Okay? And again, if we call it apples, 4 apples plus negative 2 apples, I will still have 2 apples left. Or 2x. Almost wrote 2 apples. All right, and last one here, 10x minus 7. 10x is 10 apples plus negative 7. I cannot do anything about it because negative 7 is not apples. Okay, it's not x. So it's already written in standard form, 10x plus negative 7. So here's a question. When can you combine terms? You can combine terms only when they're like terms. That's the answer to it. When they are like terms. If they're not like terms, I cannot combine them. Like terms, it means they have the same variable. When can you not combine terms is when they're not like terms. When they are not like terms. So what are like terms? And again, we already wrote it down. Like terms have the same variable. Like terms have the same variable. Like terms have the same variable. Okay? All right, moving on to a different topic. So we know how to combine terms now, right? When they're like terms. Now let's talk about any order, any grouping, property of addition. When do I have that? So in part A, we write 5x plus 3x and 5x minus 3x by combining like terms. So first of all, I need to change my subtraction into addition of the opposite. All the time. All the time. So 5x plus 3x, how can I rewrite by combining like terms? And 5x plus negative 3x. So I'm going to start with writing the original expression and expand each term using addition. So 5x I can write as 1x plus another x plus another x plus another x and plus another x. This is 5x. 5x. Right? And I can add 3x plus another x plus another x plus another x. This is 3x. By the way, x by itself is 1x because it's once, right? So I have 5x plus 3x. That's expanded form. Now let's show 5x plus negative 3x. So I have x plus x plus x plus x plus x. So what is 5x? It's 5 groups of x, right? Added together. 5 groups of x. So this is my 5x. I'm going to write it on top now. 5x. And I'm adding negative 3x. And negative 3x is kind of a here. 3x. I'm taking it away, right? I'm adding the opposite. So what do I have left is this. Okay? So what are the new two expressions that it's equivalent to? If I'm looking at this, I have 5x and I'm adding 3x. Together it's 8x. When I have 5x and I'm adding negative 3x, I will have 2x. Okay? So this way, it doesn't really matter why is any order, any grouping, is because I can write 3x plus 5x, and it's still going to be the same answer. I can put 3x right here and 5x right here, the number of x's is not going to change. Same thing here. If I have negative 3x first and I add 5x to it, it's still going to be the same thing. So the order doesn't matter. I can do any order. How about this one? Problem B. Find the sum of 2x plus 1 and 5x. So I have the sum of 2x plus 1. 2x plus 1, it's already one of the addends that I have, and I'm adding 5x. If I wrote it in expanded form, it will look like this. 2x is this, 2x plus 1x plus 1x, right? Plus 1, that's not an x. And I'm adding 5x. 1, 2, 3, 4, 5. Can I combine the x's? Absolutely. I can see that I have 1, 2, 3, 4, 5, 6, 7 x's. So I have 7x, and I have plus 1 that I can't put anywhere else. So it's just like that, 7x plus 1. It's an equivalent expression to the one that we have here. Okay? Find the sum of negative 3x plus 2 and 5x minus 3. First of all, I again see a subtraction problem. I'm going to change it into addition of the opposite. 5x plus negative 3. So I will have negative 3x plus 2. And the sum again means addition, so I'm going to add. Let's put those in parentheses just to see that what we are adding here. And 5x plus negative 3. Okay, so let's see what we can combine here. I have negative 3x and 5x, that is, I can actually combine because this is all addition, and in addition, the order doesn't matter. So I can combine negative 3x and 5x, and I will be able to combine 2 and negative 3. If I expanded it, it will look like negative x plus negative x plus negative x. It's my negative 3 groups of x, right? Or 3 groups of negative x. Then I have plus 2. Then I have 5x. 1, 2, 3, 4, 5. And then I have plus negative 3. So can I put my negative 3x along with this one? Absolutely. I can combine them. And when I do, I will have 2x remaining. Negative x and x cancel each other out, making it 0. Negative x and this one cancel each other, making it 0. This one, negative x, and this x cancel each other out, making it a 0. So I have 2x left. So 2x. Now I have 2 and negative 3 that I already know how to combine from our module 2, and that is negative 1. So my answer is 2x plus negative 1. Problem D. Find the sum of 2x plus 3y plus 7 and negative 4x plus 2y minus 4. Again, minus 4 I'm changing into plus negative 4. Learn to do it right away when you see it. And I'm finding the sum, so I'm combining them all. So I have 2x plus 3y plus 7 plus negative 4x plus 2y plus negative 4. I can put them in parentheses to separate them. However, I don't have to because it's going to be the same addition everywhere. So let's try not to expand it because this is an extra step just for you to understand it. We don't have to do that step unless you understand it. If you don't, please expand it and see it. So I have 2x and negative 4x. They are like terms. And this is addition in between them, so I have all these terms that I can combine. So 2x and negative 4x I can combine. I will also be able to combine 3y and 2y. And I can also combine 7 and negative 4. So 2x plus negative 4x is going to be 2 plus negative 4 is negative 2x. 3y plus 2y, making 5y. 7 plus negative 4 is 3. That's my answer. I cannot go any more than that because there is nothing else to combine. They're all not like terms anymore. They're all separated by the plus sign and they're not like terms. So I can't combine them anymore. All right, so that is that. That's any order, any grouping. I can group them anywhere I want in addition. Now let's look at multiplication. Again, any order, any grouping with multiplication. So let's look at the product of 2x and 3. Product means multiplication, right? So I'm multiplying 2x times 3. So what is 2x plus 3? How can I understand it? This is 3 groups of 2x put together, right? So what really is this is 2x plus 2x plus 2x. 3 groups of 2x. When I have 3 groups of 2x, I have 2, 4, 6x. 6x. That means 2x times 3 equals 6x. 3 groups of 2x put together is 6x because I know that multiplication is added, repeated addition. I have 3 groups of added 2x, and that makes it 6x. Let's look at the product of 5x and 2. 5x times 2. Now, if you want to, if you feel like it's confusing, like in addition, we don't combine like terms. And here it seems like we are combining like terms. But again, terms are separated by the plus sign. So I can't say these are 2 different terms. This is actually a one term because there is no plus sign that separates them. Okay? So I have 2 groups of added 5x. 2 groups of 5x, which is 5x plus 5x. And that means 10x because I can add them together because they are like terms. So 5x times 2 equals 10x. Let's look at product of 3x and negative 2. 3x times negative 2, product means multiplication. What that means is removing 2 groups of 3x. Removing, think about integer cards, right? Removing 2 groups of 3x. When I remove 2 groups of negative x, my score goes down, right? So basically what that is I'm taking away 3x, and I'm taking away 3x, and I'm taking away 3x. Oh, sorry, 2 groups. And negative 3x plus negative 3x is negative 6x. Negative 6x. So 3x times negative 2 is negative 6x. What we are doing, we are multiplying the numbers, right? So in both cases, in all 3 so far, we are multiplying the numbers. 2 times 3 is 6, 6x, right? Find the product of negative x and negative 9. Negative x times negative 9. Again, what it means is removing 9 groups of negative x. Removing 9 groups of negative x. When I'm removing negatives, my score goes up, right? And since I'm removing 9 of them, my score will go by 9. My score will go up by 9 of these, right? So I'm removing negative x. So I'm removing negative x. And again, I'm removing negative x. And again, I'm removing negative x. And that will happen 9 times. So my score will improve by 9x. Negative x times negative 9 equals positive 9x. I hope it makes sense. If not, we will continue practicing this. Okay, so another way to show you this is the following. So here I have 3 times 2x. It's 3 groups of 2x, right? So we did that before. What I can also show you is that 3 times 2 times x, because when I have x standing next to its coefficient, it means the coefficient is multiplied by x. 2 groups of x. 2x is 2 groups of x, and groups of is multiplication, right? So 3 times 2 times 6. If you want to do it this way, it will be easier for you to understand. Go for it. 3 times 2 is 6. 6 times x is 6x. Here I have 4 times y times 5. I know 4 times 5, 20. And 20 times y makes 20y. Okay. 4 times 2 times z. I know 4 times 2, that's 8, times z is 8z. 3 times 2 times x plus 4 times y times 5. Here I have 6x. Here I have 20y. Can I combine them? No. That's the final answer that I have for now. It's a simplified or regular form of this expanded form. That's all it is. Okay. 3 times 2x is 6x plus 20 times y is 20y plus 4 times 2 times z is 8z. I cannot do anything else because there are 3 terms separated by the plus sign. They're not like terms. That's my regular standard form. Okay? Alex says that 3x plus 4y is equivalent to 3 times 4 plus x plus y. Is he correct? Let's look at it. So 3x plus 4y, how can I rewrite it to show that they're not going to be like terms? So 3x is x plus x plus x, correct? And 4y is y plus y plus y plus y. How can I combine x and y? They're different numbers. I cannot combine them. I don't know what they are. So I can just leave it as it is. There is nothing else I can do. 3x plus 4y is 3x plus 4y. I cannot combine these. I cannot make it 12 plus xy because there is nothing related to 12 here. Okay? All right. So here's your homework. The homework is actually this page and the following one. And after that, we are going to go to lesson 2. I'll see you guys in class.